Okay, so hello and welcome back. So what I want to show you in this video is a simple basically project that we are going to do in order to see what happens to a diode when basically there is a relationship between if you have a diode in a circuit, for example something like this. If basically the voltage drop on your on your diode in this circuit and the current going through your diode, there is a relationship between that, and the relationship is basically something like this, and they call it the characteristic curve of the diode. Call it the characteristic curve of the diode. So the characteristic curve of the diode, what that is that you have the characteristic curve looks something like this, meaning that if you have a diode in your circuit, there is a voltage coming in. This is your anode. Positive is connected to anode, negative is connected to cathode, and of course depending on this resistor, there is some current going through your circuit. Now depending on this current, there is going to be some voltage drop across the two leads of your diode. And what that is basically something like this. So the characteristic curve of a diode looks something like this. So this is your voltage and this is your current, meaning that, and of course it looks actually more like this probably. It looks probably more like this, meaning that if you take this as, for example, if you take this as 1 volt, for example, and take this as 2 volts, about this is 0.5 volts, and this is 0.7 volts. So this is going to be, it's going to be something like this. Something like this. So you're going to have some curve like this. Meaning that as you increase the voltage on your diode, what happens is that all the way up to somewhere around 0.7, there is no current flowing through your circuit. This is current, this is voltage. So all the way up to about 0.7, no current, almost no current is flowing through your circuit. And then after that, the current starts shooting up like that. So now in order to do this, in order to see this practically, what you need to do is create some sort of circuit like this, meaning that you need a simple power supply, a 9 volt power supply. You need a amplifier to see what sort of current is going through your circuit, and you need a resistor here, for example a 330 ohm resistor, which basically limits the current in your circuit, and I'm going to tell you why it's going to limit the current. And you need a potentiometer here, which basically is nothing but a variable resistor, here. So variable resistor meaning that there is a knob on your potentiometer, you can turn it, and then the resistance of of this resistor, well, simply changes on the two leads over here. And then you have a diode over here as well. And then you need a voltmeter that shows you the voltage drop on the two leads of your diode. So what you're watching is basically the current going through the circuit, and therefore also through the diode, because it's a series circuit. The current that you measure here is the current going through this resistor, also the current going through this resistor, and also the current going through the diode. And that's basically the same. If I call it I, for example, I is going through this ammeter, is going through this resistor, is going through this potentiometer, and also through the diode. Now, the voltage drop across these components are of course different. The voltage drop across this resistor is different from the voltage drop across this resistor, is different from the voltage drop across this diode. And of course the voltage drop across these two are not important here. What we want to know is what is the voltage drop across this diode, basically. So what I'm going to do is create this circuit, and let's see how that actually works. So basically, first off, to create a circuit, okay, so to create a circuit, what you need is basically a couple of components. So you need something called a breadboard, which is something like this. Of course, I'm going to disconnect these wires so that you can see the breadboard properly. Okay, so now these are the wires that you can connect to your breadboard to make different connections. This is the resistor that I'm using. This here is the resistor that I'm using, and this here is the diode that I'm using. So this is the diode. Okay, so this is I cannot read it, but I suppose it's a 1N4004. Okay, it's a 1N4004, and you see that on the diode basically you have I suppose you can see. No, you can't see. Okay. Well, anyway, on the diode you have this, on one side you have a band, and this band is the cathode, the other band is the anode. So, and so basically the circuit that you need to create is basically, as I mentioned before, is a circuit like this. the circuit that you need to create is this circuit, meaning that you need a power supply. Then it comes to some ammeter to watch the current going through the circuit, and then it goes through it this basically through this resistor, which is a 330 ohm resistor or so, 330 ohm resistor. Then it goes through some potentiometer, which you can use, for example, you can use one of these potentiometers. You can see that there is, for example, this is for example, a 4.7 mega ohm potentiometer, and you can turn this. You see, you can turn this knob, and based on how you turn it, the resistance between these leads are going to change. I'm going to show you how one of these works. And this is a 10K, for example, 10 kilo ohm potentiometer. This is for example, a 22 kilo ohm potentiometer. And suppose I had, let me see if I can find a better potentiometer. Okay, so these are also potentiometers. So for example, you can see that this is the potentiometer, and then you can use for example, some screwdriver. You can use some screwdriver in order to turn this, and then the resistance of the potentiometer changes. You can just turn this thing this way, and then it changes. The resistance changes, and what changes is basically there is basically this lead over here, which is called the center tap, and there is these two leads over here. If you can see it, there is these two leads over here, and these two leads are, if you turn the potentiometer all the way to one end, then the resistance between, for example, the center tap and one of these leads is going to be 0, and the resistance of the center tap with the other lead is going to be the maximum designated here, which is, for example, in this case 50 kilo ohm. Now I have moved this to all the way to the right, for example, in this orientation, and for example, if you use an ohm meter or a multimeter, so I'm using this multimeter here. Now using this multimeter, you can see that if I set this to on, for example, and connect this to on, and connect my put this camera, I suppose, on the other. I can't. It's not possible. So anyway, you can hopefully read on this multimeter. Over here it says mega ohm, and over here it says 0, 0. So meaning that I'm not measuring any resistance. Actually, 0 doesn't mean 0, it means infinity, because the probes are actually open. Now if I connect the probes together, you can see that now I'm reading basically 0.00036 kilo ohm. So 0.0036 kilo ohm is the same thing as 0.36 ohm. So 0.36 ohm is actually 3/10 of an ohm. That means that these two wires are now connected together. Now, if I connect this one of the leads of my multimeter or one of the leads of my ohm meter to the center tap here, and not drop this, of course, one of the leads to the center tap, and the other you have to find a good way to do it, and the other tap to basically one of the leads. You can see I'm reading 6.6 ohms. That means that right now this center tap is connected to this lead over here, and then to the other lead I'm reading 47 kilo. 47 kilo. Now I'm going to use, to make it easier, so you can always use these alligator clips. So you can use a clip like this. You can use this clip over here. This is a piece of wire I have made with two clips on the ends, and then I can connect, for example, one of the wires to the center tap of the potentiometer. Of course, this is no good connection, but okay. So I can connect this to the center tap, for example, and then I have another such alligator clip I connected to the other, for example, one of the taps, and now the center tap and one of the taps of the potentiometer is connected to these two wires. And of course, since it's like a clip, it won't fall off. And then I connect this to the probes of my multimeter, like this. And what happens is that now I'm on the multimeter, I'm reading 0.65 ohms. 0.65 ohms, and now you can see what happens. If I move this, or if I turn this, you can see that the resistance is changing. 3 kilo, 4.8 kilo, 7.3 kilo, 10 kilo, 12 kilo, 15, 17, 19, 21, 22, 23, 25, 28, 30, 33, 36, 37, 39, all the way up to 47.24 kilo. And you can see that now the resistance between these two taps, this one and the tap on the left, is 47 kilo. Now the center tap, I keep the center tap and then move this wire to the other lead of the potentiometer, and then we should see 0 over there, or something like 0.7 ohms. So when the center tap has a resistance of 0 with one of the taps, then it has a resistance of maximum of that potentiometer with the other tap. So we are going to use, for example, one such potentiometer in this circuit. It's a variable resistor. You can keep changing the resistance and do different things with that. But of course, in this circuit, I'm going to use a 1 mega ohm. I don't know if that's 1 mega ohm. No, it's a 10 kilo ohm. It's a 10 kilo ohm potentiometer. I suppose 10 kilo, I already have one of them. Okay, so I'm just going to use a 50 kilo ohm potentiometer, and because I don't want to keep searching more for potentiometers. It's not really that important. Okay, so now suppose that you have your potentiometer there. Now suppose that you have your potentiometer in the circuit like this. Suppose that it's a 50 kilo ohm potentiometer. 50 kilo ohm potentiometer. And then you have a diode connected to your power, to the other end of the power supply. And the diode is forward biased, meaning that the anode is connected to positive, the cathode is connected to negative. Okay. Now this is for example, 1N4004 that I'm using, and I will use a voltmeter over here in order to watch the voltage on this diode. And this is a 9-volt power supply. Now for this power supply, what I'm going to use is this power supply here. So you see that I have basically 2 rails on this power supply. There is a different output for this rail, there is a different output for this rail. This is the output for this upper rail here. This is the output for this lower rail here. And there is another rail here for which you have basically this. You have this. Basically, you can keep changing this. You can see it change if you want to. So if I set for example, if I set this multimeter to volts, to volt DC, not AC, to volt DC, I can read the voltage over here. Right now, as you can see, the voltage is about 5.2 volts. And I can change it. 5.7, 6.1, 6.4, 6.9, 7, 7.5. So it goes all the way up to 7 volts. And you can go all the way down to 3.1 volts. So this is usually for, that's 3 amps. 5 volts, 3 amps. Okay, so this is for, you have a rail over here, but you don't have any, you cannot read the voltage or anything, and you have not much control over here. This is the kind of voltage that, for example, that you set and you don't want to change it anymore. You just, for example, need a 5 volt supply for some part of your circuit. You use this part, you use this rail, and then you connect it to your circuit. These 2 rails are basically, on these 2 rails you can change the voltage. You can keep changing the voltage using these potentiometers, and you can also limit your current using this knob. Using this potentiometer, you can limit your current, meaning that you can set your current, for example, to 100 milliamps. If you set your current to 100 milliamps, then your current will not exceed 100 milliamps. If the circuit wants to draw more than 100 milliamps, the power supply will shut the shut itself off, and so your circuit will not be, for example, damaged. If that's a problem, if more than, for example, 100 milliamp is a problem, you just set it to 100 milliamps, and then if there is some problem with your circuit, this will shut itself off, and then your circuit will not be harmed for basically for excessive current, because of excessive current. And you can basically have there is this meter over here on which you can read your voltage and also your current. If this switch is up here, you're reading voltage. If your switch is down here, you're reading current here. And of course, again, you can keep changing your voltage. Goes, for example, here goes all the way up to 20 volts, and your current goes all the way up to 2.5 amps. So that's a typical, for example, power supply that you can buy on probably eBay or somewhere like that. On eBay you would pay, like, this was an old one, so you would pay like not more than $30-40 for something like this. But of course this had a problem when I got it. This had a problem. This rail is not functioning. This upper rail is not working, and well, I didn't fix it because you have to open it and just go through the circuit, and there was a resistor inside which was fried. I didn't know the value, and I had to read the data sheet and everything else, so I just left it as it was. I'm just using this rail up, only this rail over here. For now it's more than enough for me. And so that's the power supply that we are using. Now, what you need to do is connect your circuit together. In order to connect your circuit together, now you need to use a breadboard. This is a breadboard, and on a breadboard basically you have two different areas. So you see that there is a line over here. This line basically separates this area from this area. That means that this area is actually separated from this area down here. And you can see that also there is these two rails over here, and these are also separated from this part over here. Also, these two rails are separated from this part over here. So this upper rail over here, 1 and 2, which says positive and negative, these are the power supply rails for this upper part. This is the power supply rail for this lower part. And now what happens is that, for example, in this basically the way that this breadboard works, for example, you want to connect a resistor to a potentiometer. Okay, so you connect your potentiometer somehow to your breadboard, if that's possible. Let me see if I can do it. So you see, you can push that in. There are all of these holes over here, and then you can push your, for example, you can push your resistor. You can push it in just like that. and it goes in and it's connected to your breadboard, right? And there is contacts down here in the breadboard, and it will connect your resistor to other things in the way that in a manner that I will explain in just a few moments. Now, for example, this potentiometer, what I can do is that I can hopefully connect it to this breadboard, although the leads are a little bit not really good for breadboard kind of purpose, but it seems that it does work. Actually, you can actually do it in a different way. So what you can do, you can actually use, for example, you can use okay, so now what happens is that this potentiometer has been connected to the breadboard, and I don't know if you can see properly, but there is a lead going in this column here. There is a lead going in this column over here, and the way that this works is that if you take a multimeter, so just for the sake of simplicity, I'm going to take an analog multimeter because it shows things much more properly. So I set this to on, and then if I connect these two leads together, you can see that this needle goes across this scale, meaning that things are connected or short-circuited. Okay, so I have set this to ohm times 1, for example. So now, as you can see, as I, for example, if I insert the leads in, there are basically these columns here. Now every hole in one column is connected together. You see, I'm moving to the next hole, but these holes, basically this hole is connected to all of these holes are connected together, but they are not connected to these holes down here. They are separated by this separator. So that means that if you, for example, if you have a capacitor, for example, suppose that I connect the capacitor to these two, I connect the capacitor over here. Now if I connect a resistor, for example, in the same column as one of the leads of the capacitor, now basically this resistor is connected to one of the leads of this capacitor, and then you can connect basically the other lead to something else, and so on and so forth. So that's basically how you use a breadboard. Now using this breadboard, I want to make this circuit. So to make this circuit, as you can see, one of the leads of this potentiometer has to be connected to this 330 ohm resistor, and this is the resistor that I have made. This is two 680 ohm resistors parallel, so you would get the half of the resistance of any of those two resistors, and they are the exact same resistors, so you'll get half of 680 ohms, which is 340 ohms approximately. So 340 ohms, I suppose, if I go to, you can set this to, for example, ohm times 10, and measure here. I'm reading about, so this is, as you can see, I'm not sure if you can see actually, the ohm is basically read up here, so you have 0, 5, 10, so you have 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, and 20, 10, 1, 2, 3, 4, 5, and then 30, 40, 1, 2, 3, 4, 5. So each of them is 2, right? So that's basically around 33, 30, 34, let's say. That's 340. Now I'm reading 34 here, and if I multiply it by 10, I have to multiply it by 10 because I've set the multimeter to ohms times 10. So that's 340 ohms, for example. Now 340 ohms, I connected to one of the leads of this potentiometer. So one of the leads of this potentiometer is, for example, connected here, up here, or in this column, basically. I can see it, it's connected to this, to this column. So I can connect my resistor simply up here. Now, the interesting thing about this breadboard is that very simply, now this lead of my, this lead of the resistor is just simply connected to the center tap of this potentiometer, which is actually great, because otherwise you would have to use a solder things together and then you couldn't take them apart. So it makes things very simple. And then you can see that the other end of this potentiometer is connected to the anode of the diode. So now my diode is over here, and the anode and I choose, for example, this end of the potentiometer. There are two ends. I leave this out, and I choose this end of the potentiometer. The anode of the diode is the one that doesn't have that color band. So I connect it to this lead over here. Connected to this lead over here. Now what I need to do is basically choose, I need to set up my power supply. So for power supply, you usually choose two colors that are, for example, you can choose these two pieces of wire. One of them is red, one of them is brown. So I pick the red one for positive, the brown one for negative, and I connect them here. And then I connect them here to this bus up here. And the way that this bus is connected is that it goes this way. Basically all of these holes are connected together, meaning that if I connect this here and connect this here, you can see that it's connected, also connected, also connected, also connected, but not connected here. It's connected all the way up to here, and then there is no connection. So now this, I made this my power supply bus, and then I will connect this to the power supply. This is the power supply. This is the wire that is coming from my power supply. So of course I disconnect it from the other end for now and just connect my positive to positive and negative to negative. Now if I actually connect the power supply, I will be able to read the power supply on my breadboard, which is this thing over here. If I set this to DC volts, if I set this to DC volt and positive and negative, I'm reading about 15 volts on here. You see, this is over here. You have 2, 4, 10, 20. So you have this scale, and you need to understand how to read this scale, of course. So you wouldn't see this on the camera, but you need to learn how to read this scale. For example, I have to read between 10 and 20, and then there is 1, 2, 3, 4, 5, 10 equal distances between 10 and 20, and then 10 divided by 10 is equal to, each equal distance is equal to 1. So this is about 14 volts, I suppose. And you can see that it's exactly 14 volts here. And the same thing, of course, my power supply is saying the same thing. My power supply is saying also 14 volts here. So that's that. Now my power supply is actually connected to the board. Now I, just for the sake of caution, I connect the wire from the power supply temporarily because I want to set this up still. So now the rest of the circuit is, I have to connect the cathode of this diode to negative of the power supply. So the cathode of the diode is right over here. So I connect the wire to any hole on this column, and then connect it to negative here. Any hole, basically any hole on the negative bus, you can connect it to any hole on the negative bus. That is that. And then you can see that also this one end of this 330 ohm resistor is connected to your potentiometer. The other end goes through an ammeter, and then to the positive rail of the power supply. So that means that somehow I need to set up this ammeter. So that means that the ammeter is connected to one end of this 330 ohm resistor, which would be here. Okay. So this is one end of my ammeter, this wire, and the other end of the ammeter would be the positive rail of the power supply, which is this supply bus over here. So now these go to my ammeter. Now as the ammeter, I am going to use this ammeter up here. There is this ammeter up here. I've set it to milliamps, and these are the wires here that I'm going to coming from this ammeter. So these are the leads coming down, and these are the leads of my ammeter. And you have on your ammeter, you have a positive and a negative. So what I need to do is use these alligator clips. To connect these two to the ammeter. So for example, I can connect this wire here and connect it to the negative of the ammeter, and then the other wire I can connect it here and connect it to the positive of the ammeter. And of course, well, you have to make sure that these wires are not connected together. So now my ammeter is set up. The resistor and the potentiometer are connected together, connected to the diode, and all connected to the power supply. Now the only thing that remains is that I need a voltmeter parallel with the diode, because I want to be watching the voltage on the diode here. So what I'm going to do is basically use two of these wires again to watch the voltage on the two leads of the diode. So I enter one of them connected to one lead of the diode, and another one to connect to the other lead of the diode. And as the voltmeter, I'm going to use this voltmeter here, set it to volt DC, and these are the leads or the probes. So I connect the probes here to these two wires. But I need alligator clips to do that. So okay, so I connect this. This is positive, for example, because it's the anode of the diode. So I connect it to the positive of my power supply. I'm sorry, to the positive of the voltmeter, and this is negative because it's connected to cathode. And so I connect it to the negative here. And again, you need to make sure that these things are not connected together. Now what you want to do is that you want to, for different reasons, you want to make sure that your potentiometer is set to the highest basically value possible, meaning that, for example, in this case 50 kilo ohm. So I set this to ohm times 1 kilo ohm, and then just this here. Let's see what sort of. So this is 0 now. This is now 0. That means that I have to turn it all the way to the other end so that it's 50 kilo. And now if I measure the resistance here, it's somewhere around 40. What is that? Let me see. This is 30, 40, 50. So 2, 4, 6, 8, and 10. course there is not much precision here. 2, 4, 6, this is around 7. You cannot, I mean, on an analog meter, you don't expect much precision, and it's not easy to read the scale. So whenever you want precision, you usually use, for example, a meter like this. It gives you the numbers, but the problem with this is that the numbers keep jumping around. On this meter, what you have is just a needle going across. So for specific things you use this kind of meter, for other types of things you use the other type of meter. So but that's basically that. Now what you want to do here, you have to basically note down some values here. Every kind of experiment that you do, of course, you have to get some data from your experiment and then somehow analyze the data, of course. So what I'm going to do is just take care of, get some paper here, and if you want to basically watch the voltage, so for example, what I want to do now, what happens is that this meter is going to give me the voltage across the diode. This meter is going to give me the current going through the circuit, and of course going through the diode as well. So I'm going to be watching these two meters, and simultaneously, basically, to make a reading, of course I have to keep turning this potentiometer in order to change the voltage across this thing over here. Meaning that so basically what happens in this circuit is that basically, as you change the resistance here on this potentiometer, the total resistance of this circuit is going to change. And with the total resistance changing, the current going through the circuit is going to change. And so with current basically changing, well, I'm not really sure if it's the current which is the important factor, or whether it's the voltage, but it cannot be the voltage, I suppose. I'm not really sure about this. But let me see. Okay, so now what's basically what happens in this circuit is that as I'm changing the resistance of this potentiometer, of course the total resistance in this circuit changes. As a result of that, the current changes. And as the current changes, now I'm not completely sure really how this circuit, because sometimes it's not easy to basically determine logically. For example, logically you would say that as a result of this, as a result of, for example, this happening, then that happens, and that happens, and so on and so forth. But and if this was, for example, some resistor, if this diode was some resistor, then I would say that, for example, if I change for example, one of these resistors, then as a result of that, the current is going to change, and then, for example, the voltage would be divided between these resistors. This would be a voltage divider circuit, but it's not that. And this the diode behaves basically differently in different conditions of voltage and current and so on and so forth. So you cannot say exactly what happens here. I mean, I cannot say exactly what happens here. I mean, as a result of how is it that the circuit is basically that you get that sort of graph. But you get that sort of graph. Now, why that is, we will hopefully understand later. Now, what you want to do is that you want to basically you want some values for your for the current and voltage. So basically for the voltage, if I draw a simple table over here, if this is the voltage and if this is the current, so you want to start from, for example, somewhere where the current is 0, and then you want to start from there. So let's see if we can get the current to be 0. Let's see if that's possible using the potentiometer that we have. So I'm going to basically, what I'm going to do is connect the power supply. So this is the power supply, and I have set my resistor, this resistor down here to around 50 kilo ohms. That's the highest that I can get out of this potentiometer. You can, of course, well, no, you can't. So if I connect the power to this circuit, what happens is that now I'm reading about 3 milliamps going through the circuit. 3 milliamps. Okay, so 3 milliamps is a good place to start, actually. So you see that I'm reading 3 milliamps going through the circuit, and the voltage is about 0.5 volts. Now if I keep moving this potentiometer here, now as I'm decreasing the resistance on the potentiometer, you can see that the current is is actually increasing. Now this is 4 milliamps, and the voltage is also increasing. That's now 1 milliamp. Now I think I'm at the end of potentiometer. It's now 35, 39. So now that the resistor is kind of hot, so that is now about you can see as the current is increasing, now the voltage over here is 0.6 volts, and now the voltage is about 0.75 volts, and 39 milliamps is going through this circuit. Okay, so now if I disconnect all of these things, and what we can see here now, if you basically read all of those points and then basically note down all of those voltage and current values, you would get something like this. You would get some graph. Basically, if you note down all the values for current and voltage here, you would get some graph like this. So all the way up to 0.6, 0.7, so let's say 0.1, 2, 3, 4, 5, 6, 7, and 8. This is, for example, 0.8, and this is your current in milliamps. This is your voltage in volts. So this goes all the way up to, for example, 24 milliamps. And this is, for example, you would essentially have some graph like this. .8 is about 20. About 20 somewhere over here. So you would get a graph like this, meaning that this is your voltage and this is your current, and at about 0.7 volts you have about 2-3 milliamps going through your circuit, and at about 0.75 volts the current goes all the way up to 10 milliamps, and at about 0.8 volts it keeps shooting up all the way up to 24 milliamps or something like that. So that's basically how this circuit behaves. I'm not saying that how it works, it's how it behaves. Now I don't really understand how this circuit works, meaning that as a result of what happening, that I don't understand. But that's how it works, and then we can, as we move forward, we will learn more and more about these circuits, and we will be able to understand it. it's not a problem if you don't understand something. If you do it at the time, if you don't understand it, that's fine in most cases. So that is that. And one more thing that I wanted to point out is that well, we will discuss the rest of this in the next video. We will talk a little bit about this circuit in the next video. So I'll see you in the next video.